So now, there is one caveat here, guys. The problem is that by looking quickly at this stage 3, sorry, this stage 2, here is, by the way, he's checking if it is an antivirus, whatever, right? But then I'm just gonna save your time. And here, guys, in this instruction, check, it is doing a read manage source, which is eventually calling this resource with this object. And then after that, is gonna call decrypt, which passes as a first argument this timestamp and a second argument the timestamp. Let's see what is decrypt. So decrypt is basically a, by the way, sorry, I didn't say that properly. So here in the first argument is the resources that it was just loaded, and the second argument is the timestamp. Okay, the timestamp is here, and we're gonna see what's going on there in a second. So what we can do here, guys, is we can put a breakpoint on back deserialize so that when it hits, we have an argument which potentially is our binary, right? Because it's going to be coming decrypted. And we can follow exactly the same strategy that we followed before. Because before, if you remember, we just put a breakpoint on an interested method that we want to break, and it works. Okay, so let's do that. We come back to our friend, and here what I'm gonna do is, if you remember, guys, you can put breakpoints as long as the module or the assembly is loaded in memory. Otherwise, it's never gonna be hit. Remember that, right? So here's another reminder of that source is only managed code. How do we know if the DLL is already loaded in memory? Keep in mind that we already run load here in WinDBG. It should be loaded in memory. However, if you run lm, which is a command for WinDBG to see what is loaded in memory, you can see, guys, that is not shown here the DLL. And the reason is because, as I told you before, these are commands for WinDBG, not for managed code. We need to use managed code. Keep in mind. So for that, to list what it is loaded in memory, we can run the dump domain. Okay. And you can see that now we have all the different, all the different DLLs loaded. And guess what? We get our guy. That means that it is already loaded in memory, and therefore now we can definitely put a breakpoint there. Okay, so let's put a breakpoint there. So what we're gonna do is we're gonna put a breakpoint there, similar as we did before. So we call the BPMD, and then we put what is the DLL, or the assembly. In this case is this guy, right? So we put it here. Oh, sorry, it was not this guy. It's this guy. Okay, we put it here, and then we set stop in pack dot deserialize. Okay, we hit enter, and you can see that we get an address, which is good because that confirms that we hit the breakpoint. Okay, very important. Now we run G, and hopefully we can be stopped at that moment. Okay, so let's see. We do go, it runs, and with a breakpoint we can see here, guys, that we hit the serialized one, which is great. So again, let's go by our methodology. So we do CLR stack to see what was executed. We can see this whole huge chain of execution, and then all the way to the top you will see the pack serialize, which, as we discussed, it receives 2 arguments, right? Now what is the one that we need, so we can find it out. Let me just grab this value because we're going to use it in a second, and let's just click in the first one here to dump the object. As you remember, WinDBG is going to execute the command dump obj on that object, and we can see here that it has the method table, the E class, which you don't need to understand it at this point, but we don't see any binary. So let's do the same, but for the second one, which was the second argument. Boom! You see, guys, we get our lovely MC, which tell us that we successfully get here, and then again we do our DD. Oh, by the way, sorry, we do R, and then let's see where is that guy. You know, this guy, we can see that it is here in EDX. So we do DB EDX, and here we have again our here is our object information. Here is the size, as you can see here above, is 82 to 89, which is a little bit less than that in little endian here. And then important to mention, guys, that the header starts at the offset E. You know, if you count all this, it's going to eventually be A, B, C, D, E is going to be the offset. Okay, so let's dump it. So we do again write mem. Let me grab the path quickly. Okay, we grab the path. So we do write mem where here, and we're gonna put it stage 3.bin, and then again, guys, we're gonna need to put what the offset, okay, of the MC header. So it is EDX plus E, and then the size, you know, which is poi of EDX plus 4, right? Good to go? Plus 4, right? It's right here. Okay, we hit enter, we get it dumped. It's supposed to be stage 3 bin. It's right here. So let's try to open it up. Open. All. Stage 3. And voila! We got our stage 3 binary loaded. And well, from here, guys, I mean, just quickly so that you can get interested in the next classes, right? See here, guys, it is use FTP, use PHP, you know, website visitor, and it gets the meat, guys. This is what it is exciting, not the obfuscation side. You need to get here as soon as possible and then enjoy. You see this on hook, set hook, get async, next hook. Those are key logging executions. So we are dealing with a keylogger, at least a keylogger. Something else probably, but at least that. Okay, guys. So as you can see, we dump it from memory by following the WinDBG, right? And we also were able to, you know, to successfully do it, even though it was fully obfuscated. Now, guys, there might be scenarios where it's totally obfuscated, or that you cannot, for some reason, do what we just did, right? Because if it is fully obfuscated, because, you know, it's a new technique that you're not seeing, because it's taking too much time, many things. So another option, which is also very recommended, is to actually implement this decryption or deobfuscation in Visual Studio. One use case is where, for example, that you have a ransomware which you reverse it, and now you know what is the decryption algorithm. So you really want to have a program that you control yourself, so that every time you see that sample coming in, you just pass it as an argument to your program, and you do the rest, right? You have full ownership. So what I did, guys, was to replicate this guy here. Let me just go up to show you. So basically what I did is I took this line only, and this line which passes the parameter, and I pass it, I put it into my Visual Studio. Okay, let me open it up. It's trigger, and basically what I did is I just copy those guys, and any class that is being used by that call, I just put it so that, you know, obviously it finds everything fine, and then I basically replicate it, right? That's another way. So as you can see here, you know, in the program, I have these classes, which are the only classes I need to replicate the dumping. So if you go to Dukoku or whatever is the name, you can see here that I have the instruction here, I have the timestamp here. I mean, basically we have the source code here, guys. You just need to copy paste. I mean, it's pretty cool. Sometimes though, there is some issues, like for example here in the compilation side of the house, right? So for example here in the decrypt, I remember the only issue that I had when I was compiling, it was throwing me a casting issue, and I just cast here with a byte. That's pretty much it. Okay, and then the only thing to remember also, guys, is that this guy initially was loading this object from resources, this blob, and then calling this resource, and then everything, right? In our case, since we're running it locally, we need to have a way to also load that resource. Otherwise, how we can get that undecoded, right? So because of that, what we can do is easily, and that was the actual last step that I left, so that I can show you. So what I did is, you can come here to trigger, and before that, you remember that this guy was an BMP, right? If not, don't worry, I'm gonna show you. Here in the stage 1, okay, in the resources, we have this UMA tool and CLording. You can see that the CLording is a bitmap, okay, and that's important because it's going to actually convert from bitmap, so must have that format. So in order for us to import it as a bitmap in our project, so we need to have a bitmap extension. So let's just dump this guy. Okay, we save it, and we save it as a BMP. Okay, now we go to our product. By the way, let's see it here quickly. I think we saw it before, but you see it's a BMP header. It's actually a BMP. Sometimes it's just extension. So we let's add that as a resource. So we do right click here, add new item. So we go all the way to resource file. This name, you can change it, but if you change it, you just need to change the way you call it, basically. Okay, I do add, and then this guy is gonna now send us to the GUI of the resources. I go here and I do images, then add existing file, then I pick my BMP, as you remember, and it's pretty much it. Since I just add it as it is, I'm gonna have a trigger dot resources 1, which is this. Then it's gonna get this seller. Okay, so let's see if that works. So I'm gonna recompile this guy, rebuild. It is rebuilding, and once it's done, I'm gonna open this assembly in dnSpy and see if the resources are there. It's curious because I prefer to debug in dnSpy black box than debugging here in Visual Studio, even though I have the source code. Anyways, so it's done. So let's go here. Let's open it up. Open. So we go and grab the trigger. Okay, so let's go to my projects here, trigger, vin, release. You can see the time, so you can see it was right now created. Double click on it, we go to the entry point here, go to entry point. As you see, we go here, we go to read manage resources, and see we have now this trigger resource 1, which was already there, but the important point here is to see if we have it here in resources. You can see we have the resources, and there you go. We can see that we have exactly same thing. I mean, different name a little bit, because that was sealer.bin. We have sealer, but at the end of the day, we have also sealer here, right? We just adjust it. Okay, so now the rest thing, guys, is just to basically come to the decrypt and put a breakpoint here, and we should be good to go. Another pretty cool value here, guys, is that we have this standalone implemented, so we don't have now a DLL that we need to load it from another assembly and those things. We have fully control here, which is great. So let's do a stop the previous execution. So we go here, and I do a start break on the entry point if you want. Okay, it runs a trigger. Okay, now we click continue. We get here, and now here, guys, by the way, something very important that I forgot to mention, guys, in this site, before doing that, here, guys, the second argument, the first argument is the blob of the sealer.in. The second argument is the key. This key is actually a timestamp. This timestamp is calculated here. What is that? Okay, so let's see, the timestamp is already calculated here at the runtime, but let's see it in the Visual Studio. Okay, so we go here, and then we go to the get timestamp. It is in types here. Okay, and here we have the get timestamp. No, this is not gonna help me. The okay, I hard coded because I know how I was doing it. Okay, let me open it here in the original one. I want to show you how that is being calculated. So we go to our guy right here. Sorry, no. Sorry, guys, I got confused. Is Duco here? Okay, so here is our guy calling get timestamp. Okay, so see what it's doing. The first thing it's gonna do is gonna call get module handle. Keep in mind that this is code of the DLL, right? The second stage. So when you call this get module handle, it's gonna return the base address of the DLL or the base address of the stage 1. You have 2 seconds. Wrong. Is the base address of the stage 1, which goes here. Sorry. It goes here, and then it's gonna say, hey, get that offset, add it 60, and put it in num. So let's see what is that 60. So we go to this guy, Alt F3 to open it with hue, enter, and then we go to 60. It's 16, 32, 48, 64, and here is the 60. If you remember our class in Windows binaries, this is the offset that tells where is the PE header, which in this case is at offset 80, which is here. And you can see here is the PE header. Okay, after it gets that, it says, hey, oh sorry, it says add it now 8, and that's gonna be the return, which is called timestamp. Okay, so it's 1, 2, 3, 4, 5, 6, 7, 8. So basically, guys, what we are seeing here is the timestamp. This value that is getting that guy is the timestamp. Okay, so that was just something that I really wanted to show you. And if you don't believe me, I really like that. Let me show you. Here is the X. Check this value here, 144. Okay, that's now converted to decimal, but let's call it. It's 55, F8, A7, B9. You can see here, guys, 144.2.359.225. Okay, so just short story. This guy is getting that timestamp from there, and then when it gets to the decrypt, it gets that blob, and they get the key, which is the timestamp, and then get a random value, which is random value is based on the data. So it's also always the same in every run. It's not at all different, which is also a flaw. But anyways, we can get it done. Okay. So now, guys, we were here. Oh, where we were? Now I don't know where we were. See, guys. Okay, we were here. Okay. So now we hit the breakpoint, and we see that right here. Right click memory, and see this beauty, my friends. But it has some bytes decoded before, because that was the way the loop was done. So we can easily just dump it. Okay, save. Let's save it as stage 3, but this case, let's call it DMP. Okay, now let me open an hexadecimal editor, which you can do it with Hue, by the way, but I have the demo version so that I don't get sued. So we open it up. The dump one. Okay, so now we just cut this thing. Okay, just cut it, save it, and that's it. Now let's try to open it up here, but before doing that, let me close this guy, which was the previous one dump from WinDBG, right? So we just dumped the same, but via Visual Studio, but I'm just closing it so that it don't get confused. So and I'm gonna open the dump. There you go. We have exactly the same, but with different approaches. Okay, guys, so that's pretty much it. So as you can see, it was pretty cool and amazing class, and we teach a lot of stuff, different ways to get these damn binaries, assemblies obfuscated from memory. Okay, stay tuned.